Hello and welcome back to e-sipnayan. For today's video, we're going to discuss more examples about operations involving functions. But before we proceed, do not forget to hit like, subscribe, and also hit the notification button below so that you get notified as we upload new videos. For today's video, here is the learning objective that we're going to achieve hopefully at the end, and that is to operate the functions. Let's first be familiar with the fundamental operations, which are addition, subtraction, multiplication, division, and composition of functions. Let's first discuss how to add and subtract function. So basically, this is the symbol on adding functions. That is quantity f plus g of x. This can also be written as f of x plus g of x. So basically, we're just adding the given function. For subtraction, it's the same, but the operation obviously will become subtraction. So in addition and subtraction of functions, you can only add and subtract like terms. We apply also the rules in solving algebraic expressions. Next operation is multiplication, and it is represented by this equation. So that will be f times g of x, or it can also be written as f of x times g of x. Basically, we are just multiplying the given functions. Other notation can be written like this. So quantity fg of x is equal to f of x g of x. You know very well that when terms are just beside each other, the operation is obviously multiplication. And in multiplying functions, we simply multiply the coefficients, multiply the terms, and apply the loss of exponents. So the rules in multiplying algebraic expressions also apply in multiplying functions. Another operation related to multiplication is the constant multiple, which is represented by this expression n times f of x, or written in other form such as n f of x. So basically, in constant multiple, you simply multiply the constant multiple to each term in the given function. And lastly, the operation involving division. This is the equation representing how to divide the function, that is quantity f over g of x, or f of x over g of x, where g of x, or the denominator, should not be equal to 0. Why is that? Because when the denominator is 0, the function becomes undefined. So in dividing functions, we simply divide the coefficients, divide the terms, and apply loss of exponents. So similar to addition, subtraction, and multiplication of functions, in division of functions, we also apply the same rules as dividing algebraic expression. The last operation involving functions is composition of function. And when we say composition of function, it is substituting a function to another function. Or in simpler phrases, we can define it as a function within a function. This is now the equation representing composition of function, and the left-hand side of the equation can be read as f circle g of x, or f compose g of x. The right-hand side of the equation is also an equivalent of the left-hand side of the equation, and it can be read as f of x circle g of x, or f of x compose g of x. So this is the symbol for the operation of composition. It is an open or unshaded circle. Let's now have examples, and for the first example, we are given with two functions f of x and g of x. We are tasked to operate f plus g of x, or simply addition of functions. We start by writing the equivalent of f plus g of x. We can write it as f of x plus g of x. Then afterwards, we simply substitute the values of f of x and g of x. We start by identifying the value of f of x, then substituting it to the equation. So we will now have equal sign x squared plus 2x minus 4. And let me just emphasize that the operation involved here is addition. So I will be using another color, blue, to indicate that we are operating addition. Then we substitute the value of g of x, and we write it to our solution, and that is 3x cubed minus 2x squared plus 4. Now we're done substituting. The next goal is to combine like terms. So basically, we identify like terms. Let's see if we can combine anything with 3x cubed. We cannot combine anything. That's why we simply copy as is. So we write it as 3x cubed. Moving on, we can identify like terms which can be combined, and those are x squared and negative 2x squared. So let's simplify that, and the result will become negative x squared. Moving on, let's see if we can combine anything with 2x, and obviously we cannot combine anything with 2x, so we simply copy it as is plus 2x. And lastly, let's combine the constants. We have here negative 4 and positive 4. If we add them, definitely it may cancel out because the result is simply 0. Therefore, the sum of the function given is 3x cubed minus x squared plus 2x. Let's now have another example, and this time the operation involved is subtraction. Now the given function g minus f of x can also be written as g of x minus f of x. Now in subtraction, the order matters. So g of x will be considered as our minuend, so we are going to substitute it first. And the value is 3x cubed minus 2x squared plus 4. We simply substitute it in our equation. So we copy 3x cubed minus 2x squared plus 4. Now let me again emphasize that the operation involved here is subtraction. So let me just use a blue pen to highlight the operation. Again, that is subtraction. And in subtraction, before inputting or substituting the value of f of x, we need to place it inside the grouping symbol parentheses. So we copy f of x and we place it inside the parentheses. Now why do we need to put it inside a parenthesis? It's because we need to distribute the subtraction sign or the negative sign to each term of the function. So we distribute negative to x squared, to 2x, and lastly to negative 4. So we continue solving by copying the minuend 3x cubed minus 2x squared plus 4. And afterwards, it's now time to distribute the negative sign. So that will become negative x squared minus 2x. Then from negative 4, it will become positive 4. So after distributing the negative sign, we can now combine like terms. Let's check if we can combine anything with 3x cubed. Obviously none. So we simply copy as is. That will become 3x cubed. Next, I can see like terms here, and they are negative 2x squared and negative x squared. So let's combine them. The result will become negative 3x squared. Next, let's check if we can combine anything with the term negative 2x. And since there's none, we can simply copy as is. So that will become negative 2x. And lastly, we can now combine the constants. And the constants here are positive 4 and another positive 4. Combining them will give us a result of positive 8. So we write plus 8. Therefore, the difference is 3x cubed minus 3x squared minus 2x plus 8. Let's have another example involving this time multiplication. So we are operating f times g of x. We can also write it as f of x times g of x. So the same procedure, we substitute the values of f of x and g of x. F of x is x plus 2. So we substitute. The equation will now become x, or quantity x plus 2. Then the operation is multiplication. Since we are enclosing the terms in parentheses, we can disregard the symbol, the dot symbol of multiplication. Let's now substitute g of x, and that is quantity x squared plus 3x plus 3. Then after substituting, we simply multiply the terms. So the first terms we need to multiply is x times x squared, and then we also multiply x with the second term on the other factor 3x, and lastly multiply x by 3. So the result will now become equal sign x times x squared is x cubed, then x times 3x is positive 3x squared, and lastly x times 3 is positive 3x. Now we're done multiplying the first term of the first factor. Let's now multiply the second term of the first factor, 2 times x squared, then to the middle term of the second factor and the last term of the second factor. So multiplying that, we will have 2 times x squared is positive 2x squared, then 2 times 3x is equal to positive 6x, and lastly 2 times 3 is simply equal to 6. So after operating, we will now be simplifying the expression. Let's see if we can combine anything with x cubed. Let's now combine like terms, and let's check if we can combine something with x cubed. None, so we simply copy as is, that is x cubed. Next, let's check if we can combine anything with the term 3x squared. Obviously, it can be combined with 2x squared. Adding them give us a result of positive 5x squared. Moving on, let's see if we can still combine any of the terms. Let's check if we can combine anything with 3x, and obviously it can be combined with 6x. Adding them will give us a result of positive 9x. And lastly, we cannot combine anything with the constant 6, so we copy as is. Therefore, the product is x cubed plus 5x squared plus 9x plus 6. Moving on to another example, let's have now division. G over f of x can be written as g of x over f of x. Same procedure, we substitute the values. For g of x, the value is x squared plus 2x plus 1. So we substitute it in our function. Copy x squared plus 2x plus 1. And same for f of x. We identify what's the value of f of x, and in the given, it is x squared minus 1. So let's now substitute. The denominator becomes x squared minus 1. To simplify this, we need to apply our knowledge on factoring. The factors on x of squared plus 2x plus 1 are x plus 1 and x plus 1. The same thing for the denominator, we factor it, and the factors will be x plus 1 and x minus 1. Simplifying further, we can cancel out x plus 1 in the numerator and x plus 1 in the denominator. Hence, the quotient of this function is equal to x plus 1 over x minus 1, and that is the answer. Let's now have an example involving series of operations. So we can write this as 3 times h of x all over g of x. So since we have here a constant multiple, we are going to multiply it to the function. So the function h of x, we copy then multiply with the constant multiple 3. So copy 3 and then substitute the value of x, that is quantity 2x plus 4, all over the value of g of x, which again we simply substitute in our solution. So g of x is equal to x squared minus 4. After substituting, we now simplify. First, the numerator. We distribute or multiply 3 to each term of h of x. So that would be 3 times 2x and 3 times 4. So 3 times 2x is 6x and 3 times 4 is 12. We now simplify the numerator. For the denominator, we simply copy. Now we check if we can still simplify this fraction, and the answer is yes. We do common factoring for the numerator. The GCF is 6. So we can bring out 6, and then the remaining factor inside the parentheses will become quantity x plus 2. Now, you need to recall how to do common factoring. For the denominator, we can still factor x squared minus 4, and that is quantity x plus 2 times x minus 2. Simplifying further, we can cancel out x plus 2 in the numerator and x plus 2 in the denominator. Hence, the result is 6 over x minus 2, and that is the answer for this example. Moving on to another example, let's now try to operate composition of function. So this function can also be written as f of x circle g of x. So I discussed a while ago that when we say composition of function, it is inputting a function within another function. So g of x will be substituted as x to f of x. So now we let x be equal to g of x, where g of x is equal to x squared minus 4. This is now the value we're going to substitute to f of x, which is x minus 2. So we simply substitute the value of g of x to f of x. So now we'll have x minus 2. This is the value of f of x, and all x's here will become g of x. So x will become quantity x minus 4 minus 2. Then we simplify. We can now remove the parentheses and we can simply write it as x squared minus 4 minus 2. Then combining the constants will give us a simplified form. So we're going to combine negative 4 and negative 2. Hence the result will become equal sign, copy x squared because we cannot combine anything with it. The negative 4 minus 2 is negative 6. Hence, the result is x squared minus 6. And last example, let's have a series of operations. We can write this as 3 g of x circle f of x all over h of x. Now, we substitute one at a time because this one involves a lot of operations. So, we first simplify 3 g of x. So, we copy the constant and multiply 3. Then substitute the value of g of x, which is quantity x minus 3. Then copy the operation circle or composition, an open circle, f of x all over h of x. Now again, we substitute the value for h of x, which is x squared minus 1. Now we simplify further the numerator before we apply the composition of functions, because we're going to input f of x as the value of x in the simplified form of 3 quantity x minus 3. So simplifying further the numerator, we get 3 times x, 3x, and 3 times negative 3 is negative 9. And again, we're going to do composition of function by inputting f of x to 3x minus 9. We just simply copy the denominator x squared minus 1. Let's now perform the operation on the numerator. We now let x in the numerator be equal to the value of f of x, which is 3x. And we are going to substitute it in the given 3g of x, which is 3x minus 9. Afterwards, we can simply substitute. Hence, to simplify the numerator and perform the composition of functions operation, we substitute. So we have 3. Then the value of x will become f of x, which is 3 of x. So that will be quantity 3 times x rather. Then copy minus 9. And then all over, we copy the denominator, which is x squared minus 1. We simplify further the numerator. 3 times 3x is 9x. Copy minus 9 all over x squared minus 1. Again, we can still simplify this by doing common factoring on the numerator. So we bring out the GCF 9, and what's left in the factor is x minus 1 all over the factors of x squared minus 1 is x plus 1 times x minus 1. Simplifying further, we can cancel out x minus 1 in the numerator and the x minus 1 on the denominator. Hence, the final answer will now become equal sign 9 over x plus 1. And that concludes this video. Let me just share some points to remember for this. First, we operate functions like how we operate algebraic expressions, and all answers must be expressed in simplified form. So I hope we were able to achieve the learning objective for today, and thank you for watching. See you again in the next video.